Welcome back, my 8th grade data detectives. Today, we're going to explore exactly why math isn't always a straightforward path. I'm so thrilled to have you here for this explainer because we're going to completely upgrade how you look at the world of numbers. When we first start learning about graphs and equations, it's super easy to fall into a specific habit. We get so used to drawing neat, perfect, rigid straight lines. But today we are going to bend the rules, literally. I want you to really think about this question right here. Is everything in math just a straight line? Because assuming every pattern is a straight line is a massive trap, and it will absolutely lead you to the wrong answers. If you try to force a straight line onto a world that loves to curve, you're just going to miss the real story the data is trying to tell you. Section 1. Beyond the straight line, seeing the curves in our world. To completely rethink how we see relationships between numbers, we've got to open our eyes to the unexpected turns all around us. And this beautiful quote from Ecclesiastes chapter 3, verse 1 brilliantly illustrates our big idea. It reminds us that for everything there's a season and a time for every purpose under heaven. Think about it. Just like the physical seasons change and cycle in nature, winter thaws into a rapid spring, summer peaks, and autumn slowly cools down, mathematical relationships have their own seasons. They curve, they bend, and they grow at entirely different rates. Nature isn't just some flat, constant line, and mathematics isn't either. Moving right along to Section 2, Why Spotting Curves Matters, Preparing for the Real World. Now, you might be wondering, why do we even need to care if a path is straight or curved? Well, recognizing these shapes is the absolute secret to choosing the right analytical tools. The crucial difference is captured right here in this comparison. On one side, we've got linear relationships. Think of this like putting your car on cruise control. It's a constant rate, a steady speed, and it creates a perfectly straight line on a graph. But then we have nonlinear relationships. This is where you're stepping on the gas, then hitting the brakes, then accelerating again. The speed is constantly changing, and that results in curves, bends, and sometimes even wild zigzags. You're going to spot these changing speeds everywhere in real life. Take population growth. It doesn't usually add the exact same number of people every single year, right? As more people are born, the population grows faster and faster, curving upward. Actually, fun fact, if you could fold a single piece of paper 42 times, its thickness would literally reach the moon. No way, right? But that is exponential nonlinear growth in action. What about a bouncing ball? It speeds up as it falls, hits the ground, and slows down as it rises back up. That is a constantly changing speed. Temperature shifts, money growing in a savings account, or the way a disease spreads through a community, none of these operate on cruise control. They are profoundly nonlinear. Section 3. Clues in graphs and tables, being a data detective. The visual evidence is usually the easiest to spot. If you trace the line on a graph and it looks like a U-shaped smile, swooping down and back up, or maybe a steep mountain peak instead of a rigid stick, boom, you found a nonlinear function. A straight line has 0 bends, so if your line is bending, you instantly know the rate of change is not constant. Check out this table here. We can actually spot a curve without even drawing a graph. Look at the x values on the left. 1, 2, 3. They're moving up by a steady +1. Now look at the y values. 2, 4, 9. Let's look at the differences between those y values. To get from 2 to 4, we jump up by 2. But to get from 4 to 9, we jump up by 5. The difference jumps from +2 to +5. That changing gap is the ultimate clue that the rate is accelerating. It's not constant, so for sure it is non-linear. Section 4. The power of equations, the math behind the bend. Okay, here is a huge giveaway before you ever even plot a single point. When you see an equation like y equals x squared, you need to immediately look at that little number floating at the top, the exponent. That little exponent is literally the engine that drives the curve. Instead of just multiplying by a steady number, squaring a number makes the answers explode in size faster and faster as the numbers get bigger. That rapid acceleration is exactly what bends your line into what we call a parabola, which is that beautiful U-shaped curve. Section 5. Put your skills to work. Time for a rapid-fire challenge. All right, let's test those brand new curve spotting skills together. Question 1. Think fast about that little exponent we just discussed. What does it do? Does it make a steady straight line, or does it make a growing curve? If you said nonlinear, you absolutely nailed it. That exponent means acceleration, which always means a curve. Let's look at question 2. A table shows y values changing by +1, then +3, then +5. Remember the table clue we looked at earlier?
If those jump amounts are different every single time, what does that mean? It means the speed is changing. So no, this is absolutely not linear.
Question 3. Picture that mountain or hill shape in your mind right now. If the line goes up, bends, and changes direction to go back down, you already know the answer. A straight line doesn't just change direction. So yes, a hill shape is entirely nonlinear.
Question 4. Which equation is nonlinear? Y equals 2x or y equals x squared? Keep your eyes peeled for the one with the exponent, because that's the one that speeds up and creates our bend. Y equals 2x is just steady multiplication. That's our cruise control. But y equals x squared has that exponent. So y equals x squared is our nonlinear equation. And our final question, question 5. How can you tell if a relationship is not linear? To sum up all your detective work today, if the graph curves like a smile or a mountain, if the equation has an exponent, or if the data table has unequal jumps, it is absolutely nonlinear.
Section 6. Wisdom Beyond the Classroom, the HeroesMart Academy Philosophy.
We've just spent all this time learning how to spot patterns in numbers so we don't make mathematical errors, but navigating the real world requires spotting patterns in our behavior too. Look at this profound statement. Education without morality will hurt. Being brilliant at spotting data patterns, acing your algebra test, and understanding how the world works is wonderful. But pairing that sharp education with solid biblical morality is really the only way to avoid making choices that harm yourself and others. Knowledge gives you power, but morality gives you direction. Without a moral compass, all the education in the world can honestly just lead you to make bad choices faster and more efficiently.
This brings us to a really beautiful promise found in Romans chapter 8, verses 6 and 7. It promises peace of mind to everyone who keeps their minds spiritual. When you align your newly educated mind with spiritual wisdom, you don't just become a smart student, you become a wise person. You unlock a deep, lasting peace of mind that purely intellectual knowledge just can't provide on its own. It's really about educating the mind while simultaneously shaping the heart. I want to leave you with this provocative final thought to really chew on. What is the point of being smart, of knowing the difference between linear and nonlinear patterns, if you're making life choices that hurt yourself or the people around you? True wisdom is understanding the math of the universe while living out the morality of its creator. Keep that in mind as you tackle both your math work and your daily choices this week. Thanks so much for joining me on this explainer, and stay curious.